Hi guys. All right, so to start off with, if you have not watched the video that I posted that's called Radians, please stop, go back and watch it first. It's not my video. The guy does a really good job of explaining what a radian measure is, and it's going to really help out a lot. So now that you watched that, we're going to jump right into converting. So to convert from degrees to radians, you're going to multiply by pi over 180. If you're given a radian and you want to convert that to degrees, you multiply by 180 over pi. So let's go ahead and practice doing a couple of these. The first one you're given is a degree measure. We want to convert that to radians. So we need to multiply by pi over 180. When you multiply this across, we're going to get 135 pi over 180. And then you want to reduce that to 3 pi over 4. So that's a radian measure. And if you watch that video, you would understand that that is not quite half of a circle. All right, now you're given a radian measure. I can tell it's radians because it has the pi in it. We want to convert this to degrees. So you're going to multiply by 180 over pi. When you multiply this across, you're going to get negative 180 pi over 12 pi. Notice that those pi symbols are going to cross out, and you just have negative 180 over 12, which reduces to negative 15 degrees. All right, let's practice, or before we start practicing graphing these, I want to just talk about the different measurements that go around a circle. So one's degrees and one's radians. With the degrees, a full circle, hopefully you guys remember, is 360 degrees. So if I were to start at 0 and go around a full circle, that's going to take me 360. Half of a circle over here is going to be 180 degrees. If you look, this should look like a right angle there. So that puts us at 90 degrees. So we've got 90, 180. Down here it's going to be 270. We just add another 90 to that 180. Add another 90 and it takes us to 360. Radians, if we were to convert all of these measurements to radians, remember you can convert it to radians by multiplying each of those by pi over 180. You would get, it's going to be 0. I don't need to write 0. 90 degrees would be pi over 2. 180 would be pi. This would be 3 pi over 2. 270 degrees would be 3 pi over 2. And then a full circle is 2 pi. You remember too, a circumference formula is 2 pi r. It's because it's a full circle, 2 pi. All right, we're going to be using those quite a bit. Angles in standard position. So we're just graphing an angle. I know this kind of sounds silly, but something we got to do. All right, you're always going to start with the vertex at the origin. The vertex is where an angle bends. The initial side is always going to be on the positive x-axis. Initial is just starting. So that's my initial side. So that's always where we're going to start our angle. Now, the terminal side is where it's going to stop. I'm just going to make a nice little acute angle here right now. That's called the terminal side. Now, in order to tell what kind of an angle it is, we need a directional arrow. So I started here and I just made an acute angle that went this direction. I'm going to name my angle theta. And I'm going to show you, I'm going to draw a couple more graphs here just to show you the difference between a positive and a negative angle. All right, so it doesn't matter what type of an angle, positive, negative, it is. Your angle is always going to have its initial side right there. Now, I'm going to make an obtuse angle. This is a positive angle, so what that means is that it starts at my initial side and it's going to rotate in a counterclockwise position. For the negative angle, I'm still going to start in my initial position, my initial side. I'm going to make this one look exactly like the positive. The difference this time, negative, it's going to go backwards. So it's going to go in a clockwise position. It looks like it's going down first. Positive looks like it's going up first. So when I graph an angle, I can tell if it's positive or negative by which direction I'm rotating. All right, let's actually practice some of these. So first one we have here is a 240-degree angle. So what I'm going to do is I'm going to label my X and Y axes here. So I have 90, 180, 270, and 360. So it doesn't matter what angle we're graphing. I'm always going to start with my initial position right here. Now, 240, I know it's positive, so I'm going to be going in a counterclockwise position. I'm going to go up. If I go over to here, I've only gone to 180, so not enough. If I go down to 270, that's too much. So that means 240 is somewhere in this third quadrant, somewhere between 180 and 270. Make sure you show me that rotation. And I just graphed 240 degrees. Again, that's called the terminal side. That's where it ends. You don't have to label this here. But just to show you, that's what that would look like. All right, let's take a look at another one here. It's another positive angle. I'm going to label my X and Y axis. Notice a full circle is 360 degrees. Do you see how that 500 is more than a full rotation? So that means I'm going to start this, my initial side. I'm going to go around a full circle. So I just made a 360-degree angle. Kind of silly looking, but that's a 360-degree angle. To tell how much more I need to go, I'm going to need to do 500 minus 360. And that gives me 140. So I still need to go 140 more degrees to make that 500-degree rotation. So if I go here, that's only 90, 180. So 140 somewhere in between these two. That looks pretty good to me. These don't have to be perfect. All right, so do you see how it looks like a spiral? Anytime you have an angle that's more than a full rotation, more than a full circle, you're going to start to see spirals. All right, notice that this next one here is negative. So I'm still going to start my initial position. When I label these X and Y axes, usually I call that 90. I'm going to go backwards now. So this is actually negative 90 degrees. This would be negative 180. This would be negative 270, and then a full circle, so I'm going backwards. Now, if I go down here, that's too much. I'm only going negative 50, so negative 50 is going to be somewhere right there. Now, to show that this is negative, make sure you make that rotational angle looks like it's going down. All right, let's jump and try some radians. Now, these are a little bit different. These are a little tricky because we're used to degrees. We're not used to radians. So I'm going to start by labeling my X and Y axis. So over here, I always have pi. That's 180 degrees. Pi is the same as 180. This is 90 up there, pi over 2. Down at the bottom, I have 3 pi over 2. And then a full circle is 2 pi. Now, notice that this is 3 pi over 4. So what I want to do now, I'm going to convert those into fourths, just so it makes more sense. So I'm going to change, this is always the easiest one to do. I'm going to change that to 4 over 4. Because 4 over 4 is the same as pi. Over here, 2 pi, that's another always easy to do. That's going to be 8 pi over 4. 8 over 4 is 2. You're not always going to be able to change these. This time it's a 4, so I can. So this is 2/4, and this down here is 6/4. Just to kind of help give me an idea of where I need to go. I'm still going to start my initial side. Vertex is at the origin. There's my initial side. It's positive, so I know I'm going up. I'm going in a counterclockwise position to 3/4. There's 2/4, not enough. There's 4/4, too much. So 3/4 is going to be somewhere in the second quadrant. Actually, right in between those. So make sure you give me the arrow showing the direction. There is my 3 pi over 4. All right, let's try the next one. 17/3. I'm going to start by labeling my quadrants here. So I've got pi and 2 pi. Those are always the easiest. Now this is pi over 2 and 3 pi over 2. I want to change all of these into thirds. So I'm not going to be able to convert those without having decimals. So I'm going to ignore those for now. Remember, this is always an easy one. I want thirds, so I'm going to change this to 3 pi over 3. I was thinking of 2 pi, I'm going to change to 6 pi over 3 because that's the same as 2 pi. Notice that 17/3 is more than a full circle. So what I'm going to have to do is I'm going to have to at least take off a circle. I know I'm going to start here and I'm going to go around at least a circle. So let's go ahead and subtract a circle from that. That puts me, and that puts us at 11 pi over 3, which is still more than a full circle. So I'm going to draw another little loop-de-loop there, and I'm going to subtract that second circle that I just drew. And that puts me at 5 pi over 3, which is less than a full circle. So I just need to figure out where 5 pi over 3 lands, which is going to be before 6 pi over 3. So about right there. And so again, if you are more than a circle, more than one rotation, it starts to look like a spiral there. All right, one more. Now we're going to graph a negative radian. So it doesn't matter where, if it's positive, negative. There's my initial side. This time I'm going to be going backwards. So when I label these, this would be negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi, negative full circle. These are in sixths, so I want to change all these to be over 6. So I'm going to start with the easy one. That's really negative 6 pi over 6, which if you see, that's too much. So I'm not even going to mess with that one up there. Down here, if I change that to 6, that's negative 3 pi over 6. So 5 is somewhere between the negative 3 and the negative 6. So I know that I'm going to probably be closer to that negative 6/6, and it was a negative angle, so it went in a clockwise position. It went down this time. All right,